Right, so I'm going to pick the pace up a little bit. We're going to go through another practice assessment, but this time I'll just be a little bit quicker. So, first question, complete the table below for this. So all we're doing is substituting the value of x into the equation to see what it spits out as y. So 2 times a half is just 1, plus the 2 is the 3. 4 times a half is 2, plus the 2 is 4. And then 6 times a half is 3, plus the 2 is 5. So when you're doing the half and the x there, that's like a half multiplied by 2, which is the same as 2 over 2. So I do the half multiplied by the 3, it's the same, sorry, half multiplied by 3, it's the same as, rather than 3 over 4. A half multiplied by the 4, that's just the same as 4 over 2. And the half of the 6 is just the same as 6 over 2. So that value is 1, that's 2, and that's 3. And then we add 2 to those values. 2, 4, and 5. So that's straightforward. Then we draw the line, and that means plot the values. So 2, 3 is going to be here. 4, 4 is going to be here. So 2, 3, 2, 4, 4 is up here. And then 6, 5 is going to be here. So all we're doing is 2, 3 is 2 along, 3 up. Then 4 along, 4 up. 6 along, 5 up. Simple. And then you can draw a line between those points. So your line's doing something like that. Obviously use a ruler. Nice. So the trickier question here is the vertical and horizontal line. It's saying, what is the equation for this line? Well, just take a few points. Just have a think. So that point there, x is equal to 4. And y is equal to 1. Then x is equal to 4. And y is equal to 3. And then x is equal to 4. Y is equal to 5. So all that's really saying is that x is always equal to 4. For any value of y, x is equal to 4. So for your big vertical lines, your x value just stays the same. Okay. So x is always on the 4. Likewise, if it was a horizontal line, your y would always stay the same. So I did a line along here. Y would always be equal to 5. At this point, y is equal to 5, y is equal to 5, so y is equal to 5 for that. In our case, x is 4. The next 3 questions, very similar. We're just looking at equations and rearranging them. So you need to remember what you do to one side, you do to the other, and to undo something, you do the opposite. So to solve the equation here, we want to get y on one side, numbers on the other side. So I'm going to write 4y minus 3 is equal to 13, and I'm going to do my little working line, just so I know, just to keep track of what I'm doing. Now what we're going to do for this to rearrange is we're going to do BOMDAS in reverse, or BIDMAS, BODMAS, whatever you call it, but we're doing that in reverse. So we want to get rid of this one first, if I put that in orange, do this one first, and then do the 4 second, okay? So we want to move the 3 first, and then the 4 second, because we're doing BOMDAS in reverse. So to do that, how do I get rid of take away 3? Well, I'm going to add 3, and I'm adding 3 to both sides. So it's 4y is equal to 16. And then how do I get rid of multiply by 4? Well, I'm going to divide both sides by 4. So this is going to give me y on the left, and 16 divided by 4 is just 4. So what you do to one side, you do to the other side. To get rid of something, you do the opposite. And you're doing it in the BOMDAS backwards order. So this bit first, then this bit. The next question is very similar. We're going to change this to f. Okay, so how do I get rid of the lambda sign here? How do I move that over? Well, on this side, that's the same as saying v is equal to f multiplied by lambda. So how do I get rid of a multiply by? Well, I divide both sides by lambda. So if I use the method line, I'll just show it explicitly on this side. I'll divide both sides by lambda. So that means that the lambdas cancel out and give me 1, which is what happened up here with the 4. So my next line is going to be v over lambda is equal to f. Simple as that, just one step. So to get rid of this multiply by symbol, we just divide by symbol. Easy as that. Move that over there. The next equation, we've got change the subject. This is exactly the same as what we did here, except we might not end up with a numerical answer. So change the subject from y to x. We want to get x as a subject. So just like above, we're going to move the 3 over first, and then we're going to move the 2 over, because we're doing BOMDAS in reverse. So y is equal to 2x take away 3. So get rid of the 3 means adding 3 to both sides. And then get rid of multiply by 2 means divide both sides by 2. So just your 2 steps. Add 3 to both sides. Divide both sides by 2. Next one. Question 6. We can see we've got a right angle triangle. And we're trying to work out this distance in here. So you should be thinking to yourself, this is Pythagoras. There's my right angle. And I don't know the side opposite the right angle. So I'm going to be doing Pythagoras add. So when you don't know the longest side, you're adding the square of both of these sides to give you this. So it's going to be 24 squared plus 7 squared is equal to x squared. Let's get a calculator for this. So 24 squared plus 7 squared gives me 592. So I can say that 592 is equal to x squared. So x is equal to square root of 592, and that's equal to 24.3 kilometers. Now, if you're not sure if it's an add or a takeaway, say you did a takeaway, you would have got a number like, I don't know, 15 or something like that. Can that be 15 when we know the longest side is opposite the right angle? No, it can't. That has to be bigger than 24. So if you do the takeaway, you can say, well, that doesn't make sense, so it must be the add. So you can never really get this wrong if you do a quick sense check at the end. So add to work out the hypotenuse and take away to work out one of the short sides. The next bit is scale drawings. First bit we want to do with scale drawings is just count the boxes that we have. So on this side I've got 6 boxes, 1, 2, 3, 4, 5, 6. On this side I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. On this side I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 again. On here I've got 1, 2, 3, 4, 5, 6. And then the hard bit is this diagonal. I can't count the length of boxes diagonally. I have to go vertically and horizontally. So I've got 3 and 3, okay, for that one. Please note, when you are counting the boxes, you will count the box twice. Okay, so here I've got 9 boxes, and along here I've got 9 boxes. I'm counting from this point to this point, and then from this point to this point. So it looks like you're going to count the same thing twice, but you're not. You're measuring that length, which is 9, and that length, which is 9. So don't count these boxes and miss out this box because you already counted it. If we're doing a scale factor, what we need to do is multiply our numbers by our scale factor. So I've now got numbers 3, 6, and 9, which I'm going to multiply by 2/3 to give me my new dimensions. Now if I times by 2/3, it just means times by 2 divided by 3. So that's going to be 6 divided by 3, that's 2. That's 12 divided by 3 is 4. And 18 divided by 3, which is 6. So 3 becomes 2, 6 becomes 4, 9 becomes 6. And then we redraw. So I'm going to start here, which I'm going to call that point this point. So from this point, we were going 9 down and 6 along. But now I'm going to go 6 down. So 1, 2, 3, 4, 5, 6. And please use a ruler. I'll actually redraw that, that's upsetting me. Please use a ruler, it's just because the program isn't the best, so I just prefer freehand. And instead of 6 along, I'm going 4 along. Along here I was going 9 along, but now I'm going to go 6 along. So that's me done these 3 lines, and then from this point here, which is this point, I'm going to go up 6, but in this case I'm going to go up 4. Oops, that's really bad. Hey, that'll do. Now actually on this shape it's quite simple. What I could do is just draw a line between these 2 points. I could do that. However, in some shapes you can't just do that. So I'll just check I've done this right, okay? From this point to this point, it's 3 down and 3 along, which means 2 down and 2 along on our new shape. So that's 2 down to there and 2 along. So yes, I've drawn the thing right because that's exactly what I've got. So A few things to do for this. You count your boxes, label your diagram, and watch for your diagonal. You want to do an up and a long for the diagonal. So this is 3 down, 3 along. And then you just draw your shape out after you've factored your sizes. So 3 becomes 2, 6 becomes 4, 9 becomes 6. So you just have to draw all your horizontal and verticals and leave the diagonal to the very end. In this case, you just have to join the dots between here and here. But in some cases, you'll have to do something like that. So, angles, very quickly, I am going to just run through your rules. Straight line rule, angles add up to 180. You've got your opposite rule, so these angles are the same. So that's the same and that's the same. You've got your triangle, angles add up to, I'll just call that in, so that's the same as that. And that's the same as that. Your triangle, angles add up to 180. And you've got your F angle, so this angle is the same as this angle in here. And you've got your Z angle, where this angle is the same as this angle. If you remember that, that is pretty much everything. So in here, let's start nice and simple. So 65 in here, 56 at the top. So no straight line rules to begin with. We're straight into F and Z's. So there's me drawing a little F angle. So I know that this angle is 65 because that angle is 65. I can now do the straight line rule as 115. And I can also now use my triangle rule to work out this angle. So 180, take away 56, take away 65 is going to give me this angle in here. So if you do a little chimney sum, that'd be great, just to show as much work in as possible. So 180, take away 56, take away 65, that's going to give me 59. So I can put 59 in here. Then I'm right back to my straight line rule. So 180, take away 59, it's going to give me 121, because straight lines add up to 180. To get the very last angle at the bottom, I see another F angle, that angle on there. So that angle is the same as this angle, it's going to be 59. Simple. So angle AED, or that family wanted angle AED, they wanted in that, you could just write in here at the end, 59, and don't forget degrees. Make sure you show you're working, and you can draw out your F's and your Z's. So we used our F rule, we used our straight line rule, we used the triangles 180 rule. This is very straightforward. When we've got a triangle inside a circle, we should know that the angle next to the circumference is always 90 degrees, where the triangle base is the diameter. So triangle base is diameter, that angle is 90. If that angle is 90, the whole triangle has to add up to 180. So 180 is equal to 90 plus 76 plus what? So that angle in there is going to be the what? That's the 14 degrees. Simple. So 90 and 14. I'll maybe stop there for part 2.